Good day. In this video, I will teach you how to get the rotation matrix of a 3 degrees of freedom Cartesian manipulator. Okay, so let's start. So first, let's identify the rotation matrix equation of our Cartesian manipulator. Okay, so this is the rotation matrix of our Cartesian manipulator is R04. So it is equals to the product of four rotation matrices from the base up to the end effector. So from R01, then R12, R23, and R34. So we will derive each matrix, the four matrices, so that we can get the the rotation matrix of our Cartesian manipulator. So because this is a Cartesian manipulator, every joint is a prismatic joint. So this we will have here a rotation matrix which is equals to identity matrix. Okay. So again, to derive the rotation matrix, so we will start at R01. Okay. So R01 is from frame 1 is from frame 0 to frame 1. Okay. Then we need uh we need stationary matrix first at the left side. Then we will multiply it to the rotation matrix, the moving rotation matrix of our of our uh, of our joint, which is this joint 1. Okay. This is the first joint. So to derive it, uh, as I said, or as I lectured from my last video of rotation matrix, we will find first where is theta 1. Okay, but this is a Cartesian manipulator, so our joint variable here is d, okay, or d sub n. We have here d sub 1, but d sub 1 is not a variable or parameter for rotation matrices. Okay, d1 is not used in a rotation. D sub n is not used as parameter for rotation matrices. So because the Cartesian manipulator, especially the first joint, from base up to the first joint, has no theta 1, our moving rotation matrix will be an identity matrix. Okay. So if we don't have a joint, a revolute joint, which the joint variable is theta, then our moving rotation matrix will become identity matrix. Okay, so after having the moving rotation matrix, now we will go to our stationary matrix. So to derive the stationary matrix, okay, so we will look at the directions of our axis to axis at frame 1 and frame 0. So we will start at the projection of x sub 1 on x sub 0. So it is 1 because x sub 1 and x sub 0 is pointing to the right. What are pointing to the right? So this is 1. Next, because we already have a 1 in our column of x sub 1, okay, we will make the next rows both 0. Okay. Next, the projection of y sub 1 to x sub 0, y sub 0, and z sub 0. So, y sub 1 is pointing downward. This is y sub 1. Okay. So, its projection on x sub 0 will be is 0 because x sub 0 is perpendicular to y sub 1. So, this is 0. Next, y sub 1 on y sub 0. Y sub 0 is perpendicular to y sub 1. So, this is also 0. Then, y sub 1 on z sub 0. So, y sub 1 is pointing downward and z sub 0 is pointing upward. They are both on the same axis. But because z sub 0 is pointing upward, so it has a different direction than y sub 1. So, our projection of y sub 1 on z sub 0 will be negative 1. Okay, because they are in the same axis, but they are pointing at the same direction. They are pointing at the opposite direction. Okay, so that is the rule. If they are both at the same axis but uh, pointing at the opposite direction. Okay, next, the projection of z sub 1 on x sub 0, y sub 0, and z sub 0. So, z sub 1 is pointing backward. Okay, pointing backward. So, its projection on x sub 0 is 0 because x sub 0 is pointing to the right. Then, z sub 1 on y sub 0. Y sub 0 is pointing also backward. So, they are pointing at the same direction. So, this is 1. Okay. So, we already have 1. Now, let's put 0 at the projection of z sub 1 on z sub 0. So, R01 is just the multiplication of our moving matrix. This is our moving matrix. Okay. Then multiply it to our sorry, this is the stationary matrix. Then let's multiply it to our moving matrix. Okay. So the answer here, because the identity matrix at the right side is an identity matrix. So the final answer will also the stationary matrix. Okay. So this is our R01. Okay. So next, let's solve R12. So because uh, these are all these are all prismatic joints. So all of our all of our uh, moving rotation matrix are identity matrix. Okay, all of our moving matrices are identity matrices. Okay, so at R12, okay, let's make this double screen. Okay, so it will be easy for you to see. Next, so this is R12. So R12, okay, R12 is at the frame of frame 1 and frame 2. Okay, so this we are in this frames already. Okay, this 2 frames. Okay, now our R12 also have rotation, also have a stationary matrix, and a moving matrix. So again, the moving matrix is also identity matrix. Okay. So this will become, so this is not x sub 1, y sub 1, and z sub, x sub 1, y sub 1, and z sub 1 anymore. Also, this is not x sub 0, y sub 0, or z sub 0 anymore. So our columns are x sub 2, y sub 2, and z sub 2. Then our rows are x sub 1, y sub 1, and z sub 1. Okay. Now our reference frame is frame 1. Then our projected frame is frame 2. Okay. So let's start. So x sub 2 is not projected on frame x on axis x sub 1 because they are perpendicular. So our answer here is 0. Next, x sub 2 is at the same axis as y sub 1, but y sub 1 is pointing downward, so we will have here negative 1. Because the projection on y sub 1 is already filled up, so our projection on z sub 1 is 0. Okay. Next, for y sub 2 column, okay, so y sub 2 is pointing to the front, and x sub 1 is pointing to the right, so this is 0. Okay. So I will just make this much faster because the split screen is is it will make us confused because it is moving while I'm filling this matrix up. So y sub 2 is at the same direction as z sub 1, but they are is at the same axis as z sub 1, but opposite direction. So we will have negative 1 and at z sub 1 and 0 at y sub 1. Okay, this is much faster. Now z sub 2. So z sub 2 is at the same direction as x sub 1. So we will have positive 1 at the row of x sub 1. Okay. So this is our stationary matrix. So R12 is a stationary matrix times the moving matrix. So the answer is also the stationary matrix. Okay. Next, let's go to the second and third frame. Okay. So at the second and third frame, we have rotation matrix R23. Okay. So let's put our final answers inside a box. So this is our final answers. Okay. This is our answer for R01. This is our answer for R12. And for our R23, so find we will derive first the stationary matrix and the moving matrix. So again, the moving matrix, because these are prismatic joints, is identity matrix. Okay, so this is our this is not our 0, 1. So this is R2, 3. So our projected frame is frame 3. Okay. So this is 3. This is 3. Then this is 3. Okay. Then for our another for our reference frame, it's already frame 2. So this will become 2 and 2 and 2. Okay. So let's go to our kinematic diagram. So this is okay. So let's make this faster. So x sub 3, this is x sub 3. It has the same direction with y sub 2. Okay. So y sub 2. So our moving matrix will be look like our stationary matrix will be look like this. Okay. Sorry, our column for x sub 3 will be look like this because y sub 2 and x sub 3 is at the same direction. Next, at the column of y sub 3, so y sub 3 is pointing downward. Okay, and x sub 2 is pointing upward. So x sub 2 is at the uh, x sub 2 is at the up direction. So sorry, y sub 3. I'm sorry. So y sub 3 is pointing to the left. Then z sub 2 is at the same axis as y sub 3 but pointing to the right. So we will have here a column of 0, 0, negative 1. Okay. Again, y sub 3, z sub 2. Okay. Sub 3, y sub 2. Then z sub 3. So z sub 3 is pointing downward, while x sub 2 is pointing upward. So we will have here a column of negative 1, 0, 0. Okay. So I hope you are following up. So this is z sub 3. This is x sub 2. So that's why there is negative 1 here. Okay, negative 1 y sub 3 on z sub 2, and also positive 1 for x sub 3 on y sub 2. Okay, so the product is the stationary matrix because stationary matrix multiplied to the identity matrix, the moving identity matrix. So this will become this. Okay. Next. Okay, so let's put it inside a box. So this are your final answers. So for our final rotation matrix, so R3, 4. Okay. So we are now at this. We are now at this these two frames. So R3, 4. Okay. So let's put here R3, 4. So let's make them all black. Okay. Let's go. Okay, so if our stationary matrix, then multiply to our moving matrix. So again, the moving matrix is identity matrix. Okay. Next, so this will become 4 because we are already projecting the fourth frame. Also the end effector frame. Okay. So this will become 3. So I hope you are getting the pattern of deriving the rotation matrices of our mechanical manipulator. Okay. So as you can see, class, the directions of these two axes, the directions of this frame of these two frame axes, frame 3 and frame 4, are at the same directions. Okay? So because they are all at the same directions, it means that the stationary matrix is also an identity matrix. Okay? You may derive it. You may try to derive it if it's really an identity matrix. So the final answer, R34, is also an identity matrix. Okay? So you may use your calculator or MATLAB. Yes, practice in MATLAB how to multiply all these matrices. We have here 4 3 by 3 matrices. One is an identity matrix. So these are the rotation matrices of R04. Then multiply them together using this arrangement. Okay, you will get the rotation matrix of R04. So that's the rotation matrix for Cartesian manipulator for our 3 degrees of freedom Cartesian manipulator. Okay, thank you.